Okay, so we now know what internet does and what is protocol. Now we are ready to tackle the last topic, which is layering principle. Speaking of protocols, we have hundreds of them in today's internet, um, and we group them into what we call layers, and we have 5 layers in the internet. Here it shows the physical layer and the data link layer, network layer, transport layer, and these are what we call application layer protocols. So why do we group them into layers? Well, group them into layers according to their functions, and there's a reason why we do it. To explain the notion of layering, I need to use an analogy. Suppose I'm ordering a book from Amazon.com, and what I do will be punching in my credit card number and the title of the book, and in the last step I will push a button ordering the book, and Amazon.com, when it receives my order, it'll find the book from the shelf and put it in a box maybe and attach a label that shows my address. And in a couple of weeks, maybe I will receive the book. But the question is it an Amazon guy who delivers the book to me? The answer is no. It's like a Korean postal service that delivers it to me. So what's going on? I ordered the book from Amazon, but it's the Korea postal service that delivers it. Well, the magic is layering principle. What happens is that when Amazon receives my order, it gives the book in the box to, say, USPS. And the USPS moves the package that contains my book from Amazon warehouse to probably an airport. Say it's LA airport. And that's it. It is not the United States Postal Service that appears at my door to deliver my book. Okay? It is, say, some airline that carries my book over the Pacific Ocean and arrives at Incheon Airport. And it's not Korean Airline that delivers the book to me. The Korean Airline gives the book to, say, Korean Postal Service. And that's why it's the Korean Postal Service that gives the book to me. So what this example shows is that we are sitting on layers and layers of services and use them. So for instance, the United States USPS doesn't talk to me, but rather it talks to Amazon.com just above it, and Korean Airline just below it, and it obviously talks to Korea PS Postal Service as well. So the interface is its customer above, its a service, some kind of service below it. It also talks to what we call the peer on the same layer. And the same to me. I talk to Amazon on the same layer, and I interface with Korea Postal Service. That's it. I don't have to know what airline carried my book over the Pacific Ocean, and I don't have to know what postal service or delivery company that Amazon used. So it makes the whole picture modular. Okay, the complexity is reduced. Otherwise, Amazon would have to deliver it all the way to, say, LA airport, and then use its own airplanes to cross the Pacific Ocean and drive some truck to my place, okay? But that's not possible. Amazon cannot do all those things by itself. So that's why it relies on some kind of service. And again, this USPS or USPS relies on another service, okay? So this service services are layered, and they are recursively called by its immediately located layer above it. So just like this, we in Internet protocols we have the same layering principle. We have 5 layers. That's what we saw in earlier slide. And each layer talks to its peer. So physical layer talks to another physical layer on the machine that it talks to, and data link layer is above the physical layer, and the data link layer talks to its peer on the same layer as well. And the network layer talks to the data link layer, and also it receives the service request from transport layer. So this structure repeats across layers. Okay, so this application layer here talks to the application layer over on this machine, and it talks to the transport layer. It requests service from the transport layer. That's it. So the whole architecture is modular. So you can change one layer without interfering with many other layers and the peers and so on. So that's the layering principle. That's why we group the protocols into multiple layers according to their functions. And speaking of the functions, these layers, the names of these layers have meaning. So physical layer, what they do is to delivering bits over some given physical medium, and that's why they are called physical layer. And there are all kinds of physical media. Suppose 2 submarines talk to each other underwater. Then the water will be their medium. And if you're using Ethernet, 2 devices talk to each other using Ethernet, then the medium will be copper wire. And some machines use optical fiber for the medium. And Wi-Fi or 5G or LTE, they use open space as the medium. So depending on what medium you have, the technology varies. You have to have a specific way of representing bits on your medium and deliver it to the other party. Once you can deliver bits over the given physical medium, then you can have the data link layer. And what they focus on is delivering a group of data bits, and we call them frames, over a single link. Okay, what do you mean by single link? A link is a logical connectivity between 2 machines without a third machine coming in between them. So if you're using Wi-Fi, your smartphone talks to the Wi-Fi access point, and there's nothing in between. No machine comes between your smartphone and the Wi-Fi IP. So that's what we call a link. Okay, and the mission of data link layer protocols is to deliver the frames over a single link, and that's it. It doesn't reach, say, a destination far away. So that's why the 3rd layer is necessary, and the 3rd layer is internetworking layer. They weave the links into a network, and those links could use different incompatible technologies. And we discussed this when we were talking about the internet, the magic of internet. So the Internet Networking Protocol, IP, is used for this purpose, to interconnect two incompatible technologies at a location called router. Okay, so separate links can be weaved into a single network, a single and global network, and when that's done, any machine can reach any other machine over this network. When that's possible, the fourth layer, the transport layer, comes into the picture, and it focuses on efficiently transporting data over a network. It's like, okay, if the internet networking layer produces a network, suppose this is a network of roads, then what transport layer does is running buses and trucks over the road network, okay, and for that matter, efficiently. So that's what the transport layer does. So internet networking layer connects individual roads or links into a network of roads or network of communication links, and then the transport layer has a capability of moving data over the network. Now, finally, the fifth layer, the application layer, uses this transport service to send and receive application data, and the application layer processes all kinds of application-specific aspects. For instance, HTTP, which serves to move HTML pages between machines, is an application layer protocol, and it uses TCP as a transport layer protocol, which in turn uses IP as a internet networking layer protocol, and so on and so forth. And where are all those layers located? Well, in practice, the physical layer, the bottom layer, and the lower part of data link layer are implemented in hardware. It could be in chips, or it could be made in a separate network interface card. And the upper part of the data link layer and the internet networking layer and transport layer, these three layers are implemented as functions in OS kernel. OS kernel is a single program, the most important program in an operating system. And these layers, these protocols, are all implemented as functions in this single program. And finally, the application layer protocol is not implemented in kernel, but is implemented in the application itself. So here I show the configuration of my web browser, and when I configure my web browser, I can change the protocol settings. I can let the browser use HTTP 1.1 or HTTP 2 and so on and so forth, which means that my browser has these protocols implemented inside as a component. Okay, so application layer protocol is implemented in the application itself. You shouldn't be confused between the application layer protocol and the application itself, because the relation between these two things is like a Korean language and Korean person. Okay, so they should not be confused. Okay, finally, there is one thing I want to explain to you, which is encapsulation and decapsulation. So when data starts from an application and is delivered over the internet to its peer, it goes through multiple layers of that 5-layer stack of protocols. So it goes through, say, HTTP, TCP, IP, and then it goes through Ethernet, and finally the physical layer of the Ethernet, and goes over the internet, and finally arrives and goes through the reverse process. It first goes through Ethernet, and then IP, and then TCP and HTTP, and finally the data itself is delivered to the application. It's like you're sending a letter to your friend. Okay, so you write your letter, That's your data. But you cannot send it as such. Okay, you have to put it in an envelope. Okay, so it's like giving it to the application layer, and the application layer will attach so-called the header. Okay, HTTP header. Okay, and the most important function of the header is specifying the destination address. It's like your envelope. Okay, envelope specifies the address to which the letter has to be delivered. Okay, so that's the most important role of the header here. But there are other roles that the header plays, but the most important thing is specifying the destination address, and it repeats again and again. Okay, it's like your letter going into an envelope. Your envelope goes into a mailbag, and the mailbag goes into the air container and crosses the Pacific Ocean. Okay, so just like that, it's like Matryoshka doll, the Russian doll. Okay, your data goes in one envelope, and this whole thing goes into another container, and this bag, along with other bags, maybe go into the air container. Just like that, your data is recursively wrapped up in headers, and those headers are destroyed when it reaches its destination. So this container will be opened when my book from Amazon, for example, arrives at Incheon Airport. Okay, and from that open air container, I will get not I, but maybe a Korean postal service will get these mail bags, and when mail bags are delivered to its own destination, it'll be open, and the letters in envelopes will come out. And finally, when this letter is delivered to me, or I will open the envelope and get the letter eventually. So that's what happens when these say data link frame arrives at its destination. The header and the trail layer, the wrapping, basically the packaging, will be torn apart, and the thing inside, the contents, will be delivered to its upper layer. And the upper layer, after some processing, will also remove its own header and take the contents, and will pass the contents to its upper layer again. And this thing happens again and again until the data itself is delivered to the application. So this whole process, the reverse process of encapsulation, is called the decapsulation. Okay, so I think that's about it for the first session. The first session dealt with the definition of internet, the concept of internetworking, and then the concept of protocols, and finally the layering principle. Okay, so we'll continue the discussion in session 2.